Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. In last class, we started numericals related to Graham's law of diffusion. See the next one. 80 ml of O2 takes 2 minutes to pass through the hole. What volume of SO2 will pass through the hole in 3 minutes? Okay, two different gases, O2 and SO2. Volume of O2 is given 80 ml. It passes through a hole in 2 minutes. Now, through the same hole, another gas SO2 passes in 3 minutes. How much volume of SO2 can pass in the same hole in 3 minutes? So, that volume we should find out. Okay. Rate of diffusion R1 by R2 equal to square root of M2 by M1. Rate of diffusion means V, volume. V1 rate of diffusion R equal to V by T. V means volume of the gas diffuses in time T. Here two different gases are there. So R1 means V1 by T1. R2 means V2 by T2. Equal to square root of M2 by M1. From this we can write this one. V1 by T1 equal to V1 by T1 into T2 by V2. That equal to M2 by M1. Here V1 means volume related to O2, that is 80. It is given. T1 means time in 2 minutes. So 80 by 2 into T2 means time related to second gas SO2. In the data it is given 3 minutes. 3. So 80 by 2 into 3 by V2, that equal to square root of, here M2 means molar mass of SO2 64, M1 molar mass of 32. By doing calculation, finally we can get V2 equal to 120 divided by root 2. So what is the option? Option A is the answer. So this much volume of SO2 can escape through the same hole in 3 minutes. Option A is the answer. Next. Calculate relative rate of effusion of O2 to CH4 through a container containing O2 and CH4 in 3:2 mass ratio. Here effusion or diffusion almost same. So same formula we can use for both the processes. So relative rates of effusion of O2 and CH4 we should calculate. Their mass ratio is given, that is 3:2. So R1 for a mixture of gases with mass ratio M1 is to M2. Rate of diffusion is R1 by R2 equal to P1 by P2 into square root of M2 by M1. Here P1 and P2 are the pressures of the gases. So already we know that pressure is directly proportional to number of moles. Number of moles increases, pressure of the gas also increases. So P is directly proportional to N, P equal to Kn. Here K is a constant. From this, we can write P1 by P2 equal to N1 by N2. Here N1 means number of moles of first gas, N2 number of moles of second gas. So N1 means W1 by M1, N2 means W2 by M2. Here given mass ratio is 3:2 for O2 and CH4. Therefore, PO2, pressure of oxygen divided by pressure of methane, that equal to weight of oxygen divided by molecular weight of oxygen. Weight is 3, molecular weight is 32. Molecular weight of CH4 16, weight of CH4 2, that equal to 3 by 4. Now rate of effusion of O2 and rate of effusion of CH4 equal to PO2 divided by PCH4 into square root of molecular weight of CH4 divided by molecular weight of O2. So for this we can write 3 by 4. 3 by 4 into 60 CH4 molecular mass, molar mass 16, oxygen 32. Then we can get this one. So 3 by 4 into root 2. So this is the relative rate of effusion for O2 and CH4. What is the answer? Option B is the answer. Okay. Next, the process of separation of a mixture of gases by taking advantage of the difference in their rates of diffusion is known as. So in the gaseous mixture, different gases are there. they can diffuse with different rates. That means one gas can diffuse faster, another one slower, another one very slow. Like this, they have different rates of diffusion. Based on this, we can separate those gases from that mixture. This process is called, what is that? Atmolysis. This one. Distillation, adsorption, atmolysis, all of them answer atmolysis. The process of separation of gases by diffusion method is called atmolysis. Option C is the answer. This is the application of diffusion. Remember carefully. Next. U92-235 and U92-238 can be separated by the method of diffusion. See this, uranium isotopes U235, U238 can be separated by forming their volatile solids. These isotopes, by reacting with the fluorine, we can convert them into volatile solids. Those are U235F6, U238F6. Volatile solids means on heating, these solid substances are converted into vapor state. So these are called volatile solids. It can be converted to volatile solid at a particular temperature. It can be converted to another temperature. So based upon this volatile solids formation, we can separate these two isotopes from the given mixture. So in this way, diffusion is used for the separation of isotopes of uranium. Option B is the answer. This one also application of diffusion. Next, go to the numerical. A space capsule is filled with neon at 1 atmosphere and 290 Kelvin. The gas effuses through a pinhole into outer space at the rate that pressure drops by 0.3 torr per second. If the capsule is filled with 30 mole percent of helium, 20 mole percent of oxygen and 50 mole percent of N2, what is the pressure drop under same condition? Okay, in a space capsule, neon, helium, oxygen, N2, all these gases are there. So neon escapes into outer atmosphere, then pressure decreased by 0.3 torr per second. In this condition, what is the pressure drop? We should find out. Okay, for the whole mixture, we should find out. Molecular weight of mixture. Molecular weight means helium, molar mass 4 and its mole percent 30. So 30 into 4 plus oxygen, molar mass 32, its mole percent 20. So 20 into 32 plus N2, molar mass 28. N2 molar mass 28. So its mole percentage 50 divided by 100. Then we can get molecular weight of mixture, that is 21.60. Okay. Next, given rate of diffusion in terms of change of pressure per second for neon, how much? 0.3 torr per second. When neon undergo diffusion, then inside the space capsule pressure decreases with this rate 0.3 torr per second. Let rate of diffusion in terms of change of pressure per second for mixture be R2 torr per second. So R1 by R2 equal to square root of M2 by M1. Here R1 means 0.3 torr per second. R2 we should find out. M1 molar mass of neon 20. M2 molecular weight of mixture 21.60. So substitute these values. From this, R2 rate of diffusion in terms of change of pressure per second for the mixture is 0.291 torr per second. Okay. Next, the rates of diffusion of two gases A and B are in the ratio 1:4. If the ratio of their masses present in the mixture is 2:3, calculate the ratio of their mole fraction. We should find out the ratio of their moles, not mole fraction here. we should find out ratio of their moles. Given R1 by R2 equal to 1 by 4, W1 by W2 equal to 2 by 3. So we know the formula R1 by R2 equal to square root of M2 by M1. That implies 1 by 4 equal to this. So from this we can get M2 by M1 equal to 1 by 16. So mole ratio we want, that means N1 by N2 equal to W1 by M1 into N2 means W2 by M2. So W1 by W2 means 2 by 3, this one. M2 by M1 means 1 by 16, that is this one, 1 by 24. So mole ratio of these two gases is 1:24. Okay students, practice well. We'll meet you in the next class.